So let's talk about a challenge that I'm pretty sure every single data analyst runs into. You've got this mountain of data, tons of potential predictors, but how do you actually pick the right ones to build the smartest, most accurate model? Well, today we're going to break down the strategies to do exactly that.
Okay, let's just jump right in with a question that feels, well, it feels totally backward. You'd think more information is always a good thing, right? But here's the crazy part. In statistical modeling, just piling on more and more predictor variables can actually make your model's performance tank. How on earth is that possible? Let's find out.
All right, so the heart of the issue, the real villain of our story here, is a concept called overfitting. This is our main opponent. It's what happens when our model gets so complicated that it starts to just memorize the data we show it, instead of actually learning the underlying patterns. And it is a super easy trap to fall into when you've got a whole bunch of variables to play with.
I mean, that is so tempting to just throw every single piece of data you have at a model, just hoping it'll find some kind of hidden magic in there. But more often than not, what actually happens is the model starts paying attention to the random noise, the little quirks that only exist in your specific training data. It ends up memorizing the past perfectly instead of learning a useful lesson for the future.
And this brings us to the central tug-of-war in all of modeling, the bias-variance trade-off. Think about it like a sports team. A simple model that's got high bias. It might not be perfect, it might miss some of the details, but its performance is pretty steady, pretty consistent. A complex, overfit model. Oh, that's the team that is an absolute powerhouse on its home court. That's your training data. But the second they have to play on the road against new data they've never seen before, they just completely fall apart. They have low bias on what they know, but sky-high variance everywhere else. Our job is to find that perfect balance right in the middle.
All right, so what's the game plan? How do we fight back against this overfitting problem? Well, our first strategy is something I like to call the draft pick. Here, we're going to act like a head coach building a championship team. Instead of letting everyone on the roster play, we are going to strategically pick only our absolute best starting lineup of predictors.
Now, the official term for this is subset selection. And, the name pretty much says it all. We go through our list of variables, we identify the real MVPs, the predictors that have the most impact, and we build our final model using only them. And the rest of the variables? Sorry, they just got cut from the team. It leads to a model that's way simpler and usually a lot easier to understand.
Okay, so when you're picking your team, you've basically got two philosophies. On the left, you've got best subset selection. This is the perfectionist's way. It literally tries out every single possible combination of players to find the absolute, undisputed dream team. The catch? If you have more than, say, 40 predictors, your computer will be running for a long time. So on the right, we have the more practical coach, stepwise selection. This is what's called a greedy approach. It just adds or removes one player at a time based on whatever gives the biggest immediate boost. It's way faster, but it's not guaranteed to find that one single best combination that the exhaustive search would have.
And here's how it works in practice, step by step. It's actually super intuitive. First, you start with an empty field, no players, no model. Then you look at all your available variables and you pick the one that by itself gives you the biggest improvement. Great. Now, keeping that player in the game, you look for the next best one to add to the team. And you just keep repeating that process one by one until adding another player just doesn't really help your score anymore. Simple, right?
Okay, so that was one approach, cutting players. But what if there's another way? Let's talk about solution number 2, the salary cap, also known as shrinkage. Now, instead of cutting players from the team, we're going to manage their influence. Think of it like a real salary cap that stops 1 or 2 superstars from eating up the entire team's budget. It forces everyone to play together.
Now, the jargon for this is shrinkage, or sometimes you'll hear it called regularization. But the idea is really straightforward. We keep all of our predictors in the model, but we apply a penalty that discourages them from having too much influence. We basically force their coefficients, their impact scores, to shrink down towards 0. We're not cutting players, we're just shrinking their egos a little bit so they work better as a team. This is a fantastic way to reduce variance and stop overfitting.
And this is where it gets really cool, because there are 2 main flavors of this salary cap. First, there's Ridge regression. Ridge shrinks all the coefficients, pulling them really close to 0, but it never lets them become exactly 0. It keeps every single player on the team, just maybe in a smaller role. Then you have Lasso, and Lasso is, well, it's more ruthless. It can actually shrink coefficients all the way down to exactly 0. This means Lasso does variable selection automatically, effectively kicking the useless players off the team for you. So bottom line, if you think most of your variables are probably useful, Ridge is your friend. If you suspect a lot of them are just noise, Lasso is the tool for the job.
Okay, stop what you're doing, because this is super important. This is one of those rules you just can't break. Before you use Ridge or Lasso, you absolutely must standardize your predictors. That just means you put them all on the same scale. Why? Well, the shrinkage penalty is applied to the coefficients, right? If one of your variables is measured in millions of dollars and another is on a scale from 1 to 10, the penalty is going to be applied totally unfairly. Standardization levels the playing field so everyone is treated equally.
So now we've got all these different ways to build a model. We could be looking at dozens of candidates. We have models from subset selection, models from Ridge, models from Lasso. So who wins? How do we actually pick the champion? We need a fair, objective judge. Well, to do that, we need some judges. And in our world, those judges are statistical metrics. You've probably heard of R-squared, but a much better judge is adjusted R-squared, because it doesn't just reward a good fit, it also takes into account how many predictors you use to get there. Other great metrics like AIC, BIC, or CP do something really smart. They try to estimate how well your model will do on brand new data by giving it a score that rewards accuracy, but, and this is key, it penalizes complexity. So the lower the score, the better the model.
Okay, I know this all might sound a bit abstract, right? A bit theoretical. But the amazing part is how easy these powerful techniques are to actually do. Let's take a quick peek at how you'd put this into practice using a common tool like R. Look, we're not going to get bogged down in a full coding tutorial here. But I just want to show you that putting these ideas into practice is surprisingly straightforward. It's not some scary, complex thing.
So for our draft pick method, there's this fantastic package in R called Leaps. And look at this. With pretty much one line of code, you can tell R to go test all the possible combinations of variables and find the best models. It's an incredibly powerful way to automate that whole selection process.
And for our salary cap idea for shrinkage, the undisputed king is a package called glmnet. What's so brilliant about it is its simplicity. You use the exact same function for both Ridge and Lasso. You just flip one little switch, this alpha parameter. You set it to 0 for Ridge, and you set it to 1 for Lasso. It's just an incredibly efficient way to put these powerful ideas to work.
Woo! Okay, we have gone through a ton of ground. So let's pull it all together and distill it down into the final playbook. The key things you really need to remember next time you're building a model.
All right, here it is, your cheat sheet. Number 1, overfitting is always the enemy. Remember, your job is to learn the signal, not the noise. 2, if you need a simple model that's easy to explain, go with subset selection. 3, if your number 1 goal is pure predictive power, shrinkage methods like Ridge and Lasso are probably your best bet. And remember, Lasso is special because it can do that variable selection for you. And finally, and I'll say it one more time, if you're using shrinkage, you must always standardize your predictors first. So we've got these two big ideas, right? You can either select your best players for the team, or you can shrink the influence of all your players to make them a better team. And that makes you wonder, doesn't it? What if we didn't have to choose between them? What if we could somehow transform our original variables into a whole new, smaller set of even more powerful ones? Well, that's a story for another time.